Hi, after the model training job is complete, we can deploy the model to cloud inference based on AIFS computing resource or deploy to edge devices. And edge deployment can be achieved with WISE-PaaS OTA 2.0 or APOP service, which are remote management tools that can remotely update applications, firmwares, or drivers. And next, in this video, we will use APOP, this service, to deploy edge inference and make predictions. Because it will communicate with the edge, both OTA 2.0 or APOP, including server side and the client side, these two parts. You need to install the client at the edge device first. And AIFS with APOP support deploy models to Windows or Linux OS. And you can see in the device I already installed the APOP agent is the APOP Edge. And you can open this Edge through web browser. If you install the APOP for the first time or you haven't installed the APOP agent, you can enter the APOP server side we call APOP Manager. You can download the agent here, and once you install the agent at your device, you need to connect the edge device, connect the edge agent with APOP server. There are several methods you can use. You can see here. There are different methods. The first method is you can use APOP mobile app. Use this app to scan this QR code. Then you can connect. But in our scenario, we are not suitable for this method. So you can download. You can use the second method. You can download the configuration file and import this file to the edge device agent. But in this case, in our scenario, we can just copy paste the token and input this token to the APOP edge. So you can see if there is a green light on edge browser, it means the connection is succeed. And in our scenario, it will activate a Docker container at the edge device. So please make sure the device already installed Docker desktop. The edge inference will running as a container at your edge device. And we can go back after confirming the device is connected. We can go back at manager. Sorry, let me implement with this. You can see this is the edge device I will use. APOP itself, it can deploy the model. In addition to this feature, it can also monitor the status, including CPU, memory, or storage usage of the edge device. Or it can power off or reboot the device. But in our case, we just use the model deployment, this feature. And with this work is already done, we can go to AIFS to do model deployment and inference deployment. And before we create an edge inference task, we need to prepare the inference code. So the inference code in our scenario, we can subscribe from catalog. Just corresponding to our previous training task, we use RNN temperature to generate a module, and we will use the RNN temperature inference this module to fit the model just we trained before, and we can subscribe here. After subscription, we can see here, and this page will list all the modules we subscribed from AIFS catalog, and we will use this one. And this inference is editable. It means you can you can activate a JupyterLab container and show its original code. Okay, since we have the inference code, we can create an edge inference now. And there are several steps. The first step is to choose the device we want to run the inference. So because we use APOP, so choose this type. And the edge device OS is Windows, so we choose Windows. And the APOP device, you can see there is no options because I haven't connect a certain APOP server with this AIFS instance. So I can use other way. I can go back to application setting here and choose the APOP to set a APOP server first. And the name can be named by yourself. So the important one is you need to fill in the APOP URL. And this URL is the APOP manager URL. We just need this part, sorry. Just need this part. And the username and password is that you can log into AIFS and the APOP. So with this, we can go back to edge inference. Choose this again. And here it will show up the option I just created. And the group list usually is the default group. And the device, it will show the address or the device name here. Choose the right one. And the second step, the ape, is to choose the inference code. It means the subscription module I just subscribed. So it's this one, RNN inference. And the container name and container port, the default name is inference. Use this name and use the default port here. And the action, we can skip this one. So just save this inference configuration. You can see it haven't deployed yet. We just configure the task, and we can deploy and wait for minutes. It will running on the edge device. At the meantime, I open the Docker desktop on my edge device. It quickly, it is so quick so to run this container inference. So you can see the edge inference is successfully deployed to the edge inference here. And let me refresh the status. You can see the deployment succeed. The deployment job is succeed, and AppHop can monitor the status, the container status on the edge device. So you can see the running status means the container, the inference container status on the edge device, like here. And it can, if you want to undeploy the inference at the edge, you can use this to undeploy. So far we just deploy the inference to the edge, but in this inference, it don't have model in this inference, so it cannot predict right now. So we have to do the following step is to do the model deployment here. So let me create another deployment task. And in here, we have to choose the target again, because the target, as usual, is the edge inference, the AppHop edge inference. And we have to choose the AppHop configuration again. And there is another type target you have to choose, because the inference at the edge, in real scenario, you can choose to deploy to local path at your edge computer, edge device, or deploy the inference to a Docker container at your edge device. So there are different targets, but in our case, we use Docker container. And the container name is the inference. This is defined when I create a edge inference task. And the deploy path use the root. And in our case, you can see, sorry, let me go back to open the edge inference code. The edge inference code is in here. Before we open the edge inference code, we can activate a activate a Jupyter Lab container to see the original code. Okay, the Jupyter Lab container already activate, and let me go back to open the inference code again. Okay, this is the inference RNN inference code, and you can see it will load RNN model and load this this model name to the edge inference. So if you trained another same structure model, but the different name, you can change the name corresponding to your own model and in here. So in our case, we use the default name here. So let me go back to model deployment. and choose the RNN model H5, this model. And the triggers, the second step trigger, we choose to use the latest model. If you have multiple versions of the same model, you can choose different type to help you filter the best model you want to deploy to real age inference. If you want to use other tab, you can choose like a specifier version. It will list all the versions here and the indicator, including loss value or IMSE here. You can see the value and depends on your need to choose the best one. But in this case, we just use the latest is enough. And we can skip the step 3. We wait for a few minutes. You can see the deploy status is saved, and it means the model deployment is finished. Then we can use Postman to input a certain data and see the output to do the prediction. If you see the cloud inference, another video about cloud inference, is the same. It is a same way to do the prediction. So choose the post function, and the difference is the post is used local host, and the input data choose the raw data in JSON format, just like the cloud inference, how cloud inference post. And here is the data, sample data you can use to post. And you can see this data. There are 12 sets of data here. And if you remember the previous video, we used 2 features to do the RNN model training. So there are, and in each set of data, there are 2 values. And we can send the request. Okay, and you can see the output is a single value here. So this is to use the past 12 set of data and to predict a value, the temperature, the value at the next time step. And this is how we can use the model to do the prediction.